When choosing between 208 volts 3-phase and single-phase power for a commercial building, several factors need consideration. Firstly, power requirements play a crucial role. 3-phase systems can deliver more power than single-phase systems at the same voltage. Secondly, motor efficiency is important. 3-phase motors are generally more efficient than single-phase motors, especially for larger loads. Thirdly, distribution costs must be taken into account. 3-phase systems require fewer wires and transformers than single-phase systems, which can reduce installation and maintenance costs. Fourthly, load balance is a factor. 3-phase systems provide a more balanced distribution of load, which can reduce stress on the electrical system. Fifthly, equipment compatibility matters. Some equipment, such as large industrial motors and commercial refrigeration systems, require 3-phase power. The general recommendation is to use 208 3-phase power for motors over 3 HP. This is because 3-phase motors provide higher starting torque and smoother running. They can handle heavier loads than single-phase motors of the same horsepower rating. They operate at a lower temperature, which extends their lifespan. They are more energy efficient than single-phase motors, especially at higher loads. Consider specific applications when deciding which system to use. 3-phase power is ideal for commercial buildings with high power demands. Large motors such as heating, ventilation, and air conditioning, elevators, and pumps, heavy equipment, for example, refrigeration units and manufacturing machinery, and many workstations requiring 120 volts. 3-phase power is essential for industrial facilities with heavy-duty motors used in manufacturing, processing, and other industrial applications. 3-phase power provides a reliable and efficient source of power for data centers, servers, network equipment, and cooling systems. In office buildings with high-density IT equipment, 3-phase power can support the increased power requirements of servers, networking devices, and workstations in modern office environments. When evaluating the need for 208 volts 3-phase versus single-phase power, it's important to delve into the specifics of power delivery and efficiency. A 3-phase system inherently provides a more consistent and readily available power supply, particularly crucial for equipment demanding steady operation. One should investigate the distinct advantages that 3-phase motors offer over their single-phase counterparts. For instance, 3-phase motors typically exhibit improved starting torque, smoother operation, and greater overall efficiency, especially in higher horsepower applications. Exploring real-world examples of facilities that benefit significantly from 3-phase power, like manufacturing plants or large commercial complexes, will clarify this concept further. Distribution costs represent another pivotal area. The infrastructure needed for 3-phase systems, while potentially more complex upfront, often translates to long-term savings through reduced wiring and transformer needs compared to distributing power across numerous single-phase circuits. Analyzing the load balancing aspect of 3-phase systems sheds light on their ability to evenly distribute electrical loads, minimizing strain on the grid and enhancing the stability of the entire electrical network. Understanding equipment compatibility is also crucial. Some machinery, notably large industrial motors or specialized HVAC systems, are explicitly designed for 3-phase power, rendering single-phase systems unsuitable. When considering that 3 HP threshold for switching to 3-phase motors, it's useful to look at the underlying engineering principles. 3-phase motors are constructed to deliver more consistent torque throughout their rotation cycle, reducing vibration and stress, thus increasing lifespan and reducing maintenance. The higher efficiency of 3-phase motors at higher loads translates into lower energy consumption and reduced operating costs over time, a significant economic benefit for businesses. Different commercial and industrial applications demand different considerations. For example, in a large commercial kitchen with numerous appliances operating simultaneously, 3-phase power ensures a reliable and stable energy supply, preventing voltage drops and equipment malfunctions. In data centers, the continuous and stable power delivery of 3-phase systems is essential for maintaining uptime and preventing data loss. In large office buildings, the concentrated IT equipment necessitates a robust power infrastructure that can handle high energy demands without compromising performance. The ability of three-phase systems to handle unbalanced loads where different phases draw varying amounts of current is another critical advantage. This ensures that even with varying operational needs, the overall electrical system remains stable and efficient. When choosing between the two systems, conducting a thorough power audit to assess the actual energy demands of the building or facility is essential. This audit should consider both current and future power needs to ensure the selected system can adequately support anticipated growth. Moreover, consulting with qualified electrical engineers and contractors is crucial for properly designing and installing the chosen power system, ensuring compliance with local codes and regulations. A well-designed electrical system, whether single-phase or three-phase, is an investment in the long-term reliability and efficiency of any commercial or industrial operation. It is important to consider the long-term operating costs when evaluating the initial investment. While three-phase systems might have higher upfront costs, the improved efficiency and reduced maintenance can lead to substantial savings over the lifespan of the equipment. The size and type of electrical loads are important considerations. Large, continuous loads benefit more from three-phase power due to its increased capacity and stability. Intermittent or smaller loads may be adequately served by single-phase power, depending on the overall demand. Another aspect to consider is the potential for future expansion. Selecting a power system that can accommodate future growth is crucial for avoiding costly upgrades later on. In the context of motor selection, it is important to look at the motor's duty cycle, starting torque requirements, and operating speed. These factors can influence the choice between single-phase and three-phase motors, even within the same horsepower range. The integration of variable frequency drives, or VFDs, with three-phase motors can further enhance energy efficiency and provide precise control over motor speed and torque. VFD allow motors to operate at optimal efficiency levels, reducing energy consumption and extending the lifespan of the equipment. Power quality is another critical consideration. Three-phase systems tend to provide better power quality with fewer voltage fluctuations and harmonic distortions compared to single-phase systems. The use of power conditioning equipment, such as surge suppressors and uninterruptible power supplies or UPS, can further improve power quality and protect sensitive electronic equipment. Compliance with electrical codes and standards is paramount. Ensure that all electrical installations meet the requirements of the National Electrical Code and other applicable regulations. Regular inspections and maintenance are essential for maintaining the safety and reliability of the electrical system. Professional electrical contractors can provide these services, ensuring that the system operates safely and efficiently. The concept of power factor correction is worth exploring. Power factor is a measure of how effectively electrical power is being used. Improving the power factor can reduce energy losses and lower electricity bills. Three-phase systems are generally easier to correct for power factor compared to single-phase systems. The use of capacitors and other power factor correction devices can improve the efficiency of the electrical system. The location of the building or facility can influence the choice of power system. In some areas, three-phase power may be more readily available or less expensive than single-phase power. Local utility providers can provide information on the availability and cost of different power systems. Furthermore, consider the environmental impact of the chosen power system. Three-phase systems tend to be more energy efficient, reducing greenhouse gas emissions and promoting sustainability. The use of energy-efficient motors and equipment can further minimize the environmental footprint of the facility. Smart grid technologies, such as advanced metering infrastructure, can provide valuable data on energy consumption and help optimize the performance of the electrical system. These technologies enable real-time monitoring and control of energy usage, allowing for more efficient and sustainable operations. Finally, it is important to stay informed about the latest developments in electrical technology and energy management. Continuous learning and professional development can help ensure that the electrical system remains up to date and efficient. Consider attending industry conferences, workshops, and training programs to stay abreast of the latest trends and best practices. In the selection process, remember that the initial cost is just one factor. Focus on the overall life cycle costs, including energy consumption, maintenance, and potential downtime. A more efficient and reliable system may have a higher upfront cost but can deliver significant savings over the long term. When evaluating different motor options, look for those with high efficiency ratings such as NEMA Premium or i3, which indicates superior energy performance. These motors can reduce energy consumption and lower operating costs. Consider the use of soft starters for motors, which reduce the inrush current during startup, minimizing stress on the electrical system and improving overall power quality. Soft starters can also extend the lifespan of motors and reduce maintenance requirements. In applications where precise speed control is needed, consider using variable frequency drivers in conjunction with three-phase motors. VFD allow for fine-tuning of motor speed, optimizing energy efficiency, and improving process control. Integrating renewable energy sources, such as solar panels or wind turbines, can further enhance the sustainability of the electrical system and reduce reliance on fossil fuels. Consider the potential for net metering, which allows businesses to sell excess energy back to the utility grid. The design of the grounding system is critical for ensuring safety and preventing electrical hazards. Proper grounding minimizes the risk of electric shock and protects sensitive electronic equipment from damage. Regular testing and maintenance of the grounding system are essential. The use of arc flash protection devices, such as circuit breakers and fuses, can reduce the risk of arc flash incidents, protecting personnel and equipment. Arc flash is a dangerous electrical phenomenon that can cause severe injuries or fatalities. Ensure that all electrical workers are properly trained and equipped to work safely around electrical equipment. The availability of spare parts and technical support is an important consideration when selecting electrical equipment. Choose equipment from reputable manufacturers with established service networks. In the event of a power outage, having backup power sources, such as generators or uninterruptible power supplies, can minimize downtime and prevent disruptions to critical operations. Regularly test and maintain backup power systems to ensure their reliability. Consider the use of energy management systems, or EMS, which can monitor and control energy usage throughout the facility, identifying opportunities for energy savings. An EMS can provide valuable insights into energy consumption patterns and help optimize the performance of the electrical system. Furthermore, conduct regular energy audits to identify areas where energy can be saved. Energy audits can reveal inefficiencies in lighting, heating, cooling, and other systems. The use of LED lighting can significantly reduce energy consumption compared to traditional lighting technologies. LED lighting is also more durable and has a longer lifespan. Consider the use of occupancy sensors to control lighting in areas that are not constantly occupied. Occupancy sensors automatically turn lights on and off, saving energy and reducing waste. In heating and cooling systems, consider the use of programmable thermostats to optimize temperature settings and reduce energy consumption. Programmable thermostats can automatically adjust temperature based on occupancy and time of day. Consider the use of energy-efficient windows and insulation to reduce heat loss and gain, minimizing the energy required for heating and cooling. Proper insulation can significantly reduce energy consumption and improve the comfort of the building. Implement a comprehensive energy management program that includes employee training and awareness initiatives. Encourage employees to adopt energy-saving practices and provide incentives for reducing energy consumption. Conduct regular reviews of the energy management program to identify areas for improvement. Continuous monitoring and evaluation are essential for maintaining energy efficiency and reducing costs. By considering all of these factors, businesses can make informed decisions about their electrical systems and optimize energy efficiency, reduce operating costs, and promote sustainability.